Hello, all listeners, and welcome to this episode of Hacker Talk. My name is Philip, and I will be your host for today's episode. What if I told you there's a new way that you can find security vulnerabilities in your code base using something called CodeQL? But what is CodeQL? How do we use it? What is the fuss about? In this episode of Hacker Talk, we're joined by Alvaro Munoz. Alvaro is a security researcher known for his work with deserialization bugs. He's a speaker at various conferences, part of Github security team, and our Hacker of the episode. Welcome to Hacker Talk, Alvaro Munoz. How are you doing today?
Thank you. Very excited to be here today.
Awesome. So for all our listeners that have no idea about who you are, how did you get into security and software? And was there any light bulb moment where you realized like, wow, security is pretty cool?
If I have to go back to that moment, then I have to go back to my teenager days, I guess, back in high school, I guess. And I was playing with computers. That was back in the 90s. I'm old, I know. But at those times, there was no public access in internet, at least in Spain, where I'm from. So basically, I was playing around with BBS. So if you are old enough to know about BBSs, I think it stands for bulletin board systems. Those were basically your computers that you were sharing access to with other people via modems, basically telephone lines. So you have to call into some other people houses and basically get respond by these BBS systems. And then you were able to browse through a number of files that were shared. And then I was visiting some of these BBS for hacking information because I was kind of interested. I learned how to program in BASIC using Microsoft MSX. Back in the day, my father told me, and then I was very interested when I got my first 486 computer and then my Pentium, and that was running on Windows, right? And I remember that when I wanted to learn about hacking, because that sounded very interesting and very cool to me back in these teenager days, then I found many information in this BBS about Unix commands and Unix operating systems, Solaris, etc. But I didn't get access to any of those systems at my home lab, which was basically this Pentium. And then I learned how to hack myself into CompuServe and get access to internet, get more docs, more documentation about these open systems. And finally, I was able to get some accounts in some servers in the US, I think, where I was able to play with all those commands that I was learning about from these manuals and tutorials that I found in. So I kept learning about programming, learning about different languages. And then basically that's where I started college, and I kind of forget about this interest, or I kind of switch interest into other topics like music, guitars, and things like that. So back when I was finishing college, I got this interest back again and kind of started my work related with computers, but it was not related with security at all. I was working in IT world, and then at some point I learned that the company I was working for, that was HP at that time, was acquiring a security company called Fortify. And then that was my chance to jump into Fortify and start working with static analysis and application security at like a professional level. And that's where I guess that everything started more seriously, I guess.
Oh, that's cool.
Yeah, no, I remember that back in the day when I started college, I had this documentation that I learned from this BBS, and I knew about things like John the Crack and John the Ripper, and then I used that in the first year of university to get access to. I don't know if I'm supposed to talk about this, but let's say that I was able to get access to the labs and play with those systems that I didn't have access to in my home. But yeah, so that was like the starting of my career at InfoSec. And then I've never broke the law, I guess, except maybe for that specific episode. But yeah, then I started like playing CTFs, and I think that CTFs has been like a really important point in developing my skills, learning about security, and really becoming very interested in security. And I started playing CTFs by myself. At some point, I was contacted by, at that time, the most important Spanish CTF team, the Intrepids, that were always at the top of the CTF score leaderboard. So they were like very good, and they are still very good. And I learned a lot with them. So before joining the Intrepids, I was basically doing like all kind of security related challenges in the CTFs, from exploitation to reverse engineering to web, crypto, everything. When I joined Intrepids, I guess that I specialized in web and like high level languages. And then that's where I basically developed my interest and my specialization. And that's where I basically end up working.
That's dope. That's dope. Do you still do CTFs?
Not that much, since I got two kids and they basically took all the free time that I used to have. So I don't know if maybe one day when they are older, I will be able to have like free time again. But so far it seems like a dream to me to be able to have like a whole yeah, hopefully in the future I will be able to.
That's so fun. Yeah, CTFs are so fun, but sometimes you spend hours and hours and hours on the challenges sometimes.
Mm-hmm. Yeah, I always recommend people approaching to me and asking, how should I get started with InfoSec or application security? And I don't know, that depends on the people, on the specific person, for example, the way that they learn or the way that they get motivated. But for me, what worked was CTFs, because I really learn how to think out of the box, how this lateral thinking that they call. And that's what got me so many vulnerabilities in years after, like being able to think in not a straightforward way, try to, think out of the box and find these malicious kind of mental models where you think how to break things other than building things. They're trying to develop this kind of
mindset.
Yeah, exactly. Mm-hmm.
Yeah, that's very important to have. It makes your code completely different, and you're so defensive now when you're writing code, I feel like.
Mm-hmm.
But how does all these roles lead to CodeQL, and what is CodeQL?
Well, basically, as I said, I started working in 45, which is also a static analysis vendor. And at some point in my career, I decided to move to GitHub. And there I was going to basically do security research. So not really bound to any tool at all, like CodeQL or anything like that. But I guess that, as we say in Spain, I don't know if there is any similar saying in English, but the goat goes to the mountains. So if you really like something, you try to do it. And that's why I started playing with CodeQL a lot within GitHub. And today I end up leading a team of junior security researchers which are using CodeQL to find vulnerabilities in open source software at scale. So yeah, back to your question, what is CodeQL? CodeQL is a static analysis tool or solution, which will basically help you to find vulnerabilities by analyzing the source code at rest, if you want to put it that way. We are not running the source code at any moment, which from one side or one point of view, it will give you visibility into the whole source code. When you use something like black box approach, like running tools like Verb or any dynamic analysis tools, you will be able to find vulnerabilities in the code that you are able to exercise with your requests or whatever. But there will be many vulnerabilities that you may not exercise because you didn't trigger correctly. And you want to be able to trigger them if you don't have visibility in the source code. If you don't see that the source code is checking for this query parameter, and if it's present, then it's going to do this or that. And then you want to be able to trigger that dynamically. So I always found like a static analysis more complete in that sense, in the sense that you have full visibility, and sometimes you will find bugs that then you are not able to trigger because whatever there may be bugs in some places in the code which cannot be exercised from the outside, from the attack surface. But I guess that's the upside of static analysis, the visibility into the whole code base. And the downside is that it's static. So basically you are not running the code. You have to emulate what the code could be doing if it would be run. So in some places, in some languages like Java, which is a statically typed language, this is kind of a very accurate analysis. In some other languages, such as JavaScript, maybe, or Python, you have to do a lot of assumptions about what's the type of this object. In Java, you always know the type, but for example, in Python, you have to do assumptions, and based on those assumptions, you will have better results or worse results. And that's basically CodeQL is a platform to perform static analysis. Is used a lot to do what we call variant analysis. So basically, imagine you are a security engineer, you receive a report from an external security researcher telling you that they found a vulnerability in your code. And then you can take that code, understand what was the vulnerability, and then model that with CodeQL. Model that means that express the same pattern that this vulnerability is defined for, and then express that in CodeQL, so you will be able to run that query and find similar patterns appearing in the very same code base, so variants of that other bug. Or once that you have that bug pattern model, you can run that at scale on hundreds of thousands of repos, and then be able to quickly scale and find vulnerabilities in thousands of repos.
So you gotta be good at writing queries for the thing.
Yeah, and this can be a little bit not problematic, but CodeQL is a declarative language, so people is more used to work with imperative languages. So languages where to define how you want things to happen, right? If you think about Java, Python, JavaScript, all of those are imperative languages where you tell the program what you want to do, loop through all these items in this array, and this for each of them do this or that, check if they start with this prefix, and then if they start to this or that. That's following a receipt. And a declarative language is completely the opposite. You just specify what you want instead of the how. And then the compilation engines will basically just figure out how to connect the database tables or how to get the information that you want. And if you think about a declarative language, you will probably come up with SQL, where you say okay, I want to all the users where the username is, I don't know, Philip, and the last name is whatever, and the age is whatever. And then you will get those results, and then you don't need to tell this SQL engine how to join those tables, how to get the information from
them. Black magic for you.
Exactly. And you will just get a list of the users, and you will just express in a very expressive language, select from users, select the username, the age, and the address. And then it may connect three different subtables or whatever it's implemented in the backend of the database, and it will get the results for you. And CodeQL is exactly that. You don't tell the engines how to get you the stuff that you are after, but actually you tell them okay, I want all the method calls to a method call execute, for example, or eval, where the argument to this method comes from untrusted data, from data that can be controlled by a user. And that's it. Just return me all the places in the code that are called eval with untrusted data. And then CodeQL will return you all those places. So you can use CodeQL to find vulnerabilities, for example, modeling a vulnerability like a SQL injection, for example. Or you can also use CodeQL to explore a code base. If you are into code audits and code review, then if you are faced with 10,000 lines of code, then you don't even know where to start looking at for vulnerabilities. But with CodeQL, you can start asking questions to the code base, right? Like, what are the places where untrusted data enters this application? What are the places where, I don't know, deserialization operations are performed? No matter if we have evidences that the data being deserialized is coming from untrusted data or not, I want to get all these places where untrusted data is being deserialized, or all the places where I/O operations are performed, like files are being opened, read, or written to, all the places. And then you can ask questions about the code. And then as a manual code reviewer, you can use that information to drive your audits and be like more effective, more.
That's really good overview. I think it's a really cool approach to it. Absolutely. And being able to find, like you said, evolve, it's a very, very bad feature. How long have you been in CodeQL?
Well, I joined GitHub like almost 3 years ago. So January will be 3 years. And I started like really playing with CodeQL like maybe 2 years ago. And yeah, I can tell that even though the learning curve is a little bit steep, once that you get to the basics of working with a declarative language, which you may not be used to, and once that you get used to working with expressing these patterns in a declarative language, then it's much easier than you may expect. So I think that you need to stick around for the time that it takes to learn the basics, and then you will get rewarded with a very powerful tool to find bugs, to model other people's bug. I have done this a lot of times. Like someone reports a CVE, and then during the weekend, then Monday I come back to work, and then I model that CVE with a CodeQL query. I run it on all GitHub repos, and I find like many vulnerabilities that we report to the maintainers. And that gives you a really powerful tool. I mean, I can't imagine another tool that runs at this scale. Like dynamic analysis is great for when you are focusing on a single application. But if you want to run that at scale, like thousands of applications, just thinking about having those thousands of applications up and running, like setting them up, and that's something that is even impossible. And with the static analysis, with, for example, languages like our interpreted language, you don't even need to compile them, like Python, JavaScript, Ruby. You can just throw them to the CodeQL extractor, and that will basically take the source code. It will extract what is called the AST, the abstract syntax tree, which is basically an abstract representation of the source code. And that will store that AST in a CodeQL database. And then you are ready to query that database with whatever queries you want to run on them.
Okay, so if I want to do this on a local local repository, I can use set up CodeQL with a repo. But what if I write a new cool exploit and I want to search entire GitHub for this? How can I, as a consumer or private person, do that?
So this is still possible in lgtm.com, which is
lgtm.com.
Well, lgtm.com is a platform that unfortunately is going to be deprecated. So if you want to play with lgtm.com, you have to rush. Basically, the idea is that in lgtm.com, you have a CodeQL query console. So you can just go to this site, go to the query console and start writing CodeQL and then running those queries on all the hundreds of thousands of open source repos that we have onboarded in LGTM. And then there are some scripts out there. So if you are interested in getting access to these scripts to run these queries at scale on these hundreds of repos, then you have to visit our Slack channel that I will provide you with a link later because I don't have it right now. But it's private channel, but it's open to anyone that wants to join, basically. So anyone that asks for an invitation, they get the invitation. And then we basically discuss things about CodeQL. You can ask any question and talk directly with the CodeQL engineers, with the security lab researchers that use CodeQL. So different perspective, the people that create and write CodeQL and the people that use CodeQL to find security vulnerabilities, and just ask your questions, etc.
That's awesome. That's really useful to have a community like that. How is the user adoption of CodeQL? Is there mostly people that use it for bug bounties, or?
So CodeQL is being adopted mostly in the form of code scanning. So code scanning is a feature that you can enable in your open source repos in GitHub, where basically every time that you submit a commit or a PR in your repo, then it will be automatically scanned by CodeQL, right? So in this way, if you introduce a security vulnerability in your source code, you will be notified as soon, or you can even make like a check and make these PR fails if they have like a CodeQL or code scanning vulnerabilities. So I would say that is the most adopted use of CodeQL by developers integrated into the CI/CD pipelines. Obviously, there are many security researchers that are using CodeQL for looking for vulnerabilities like we do at Security Lab. But if you look at the numbers of developers using CodeQL integrated into their CI/CD pipelines versus the security researchers, I would say that probably developers are using it more than security researchers. And that's a good thing because mostly static analysis are known to be a little bit noisy in terms of false positives. But CodeQL was developed with this developer-first approach where they prefer to have a false negative, so not to report something, over like flooding the developers with false positives. So if with any static analysis tool, you have to move the needle between these two, like being very accurate and just report things that you know are security vulnerabilities for sure. Or if you move the needle to like what I call the researcher mode, you start getting more false positives and also less false negatives. And as a security researcher, I don't mind like triaging and reviewing 100 false positives if one of them is a true positive, right? For example, if I have to review in Log4j 100 false positives and one of them is the Log4j issue, like the true positive, then
holy grail.
That's time well spent for a security researcher. Now, from a developer point of view, if you receive a report and it's 100 false positive, the next thing that you're going to do is basically disable that tool and not run it ever again. So this is the reason that when running CodeQL, the default mode is running in a developer first mode where it's very accurate and try to get as most accurate results as possible. Now, as a researcher, this is completely flexible tool. You can enable this research mode by making the analysis maybe less accurate, but also will result in less false negatives.
That's good. Because you're touching on an important topic here, because I feel like a lot of developers, they get this type of static analysis tools, and then if there's too many false positives, you just turn them off in the CI. What would you say? I know we have a lot of listeners that have they've tried to achieve similar stuff as CodeQL does in their CI system, but they're using like all these type of static linters and ways of describing bad patterns in the code. Do you think they should just get rid of all the old linters and replace their CI with CodeQL, or?
Well, linters may be used for a number of reasons, like not just security, also quality, following some policies about conventions in your company or whatever. So if you're using linters for that, then obviously CodeQL may be used for that, but then you have to write all the queries for yourself. So the queries that comes bundled with CodeQL are security related and some quality related queries. Right. If you use lintering for things like, having some convention about, if using single quotes or double quotes or things like that, then that's something that CodeQL is not going to. Now, if you think about a static analysis, there is like a large spectrum where you can move from very simple AST grepping, right? So basically, you can even go farther in this spectrum to just grep things. But this is not useful because it will get a lot of false positives. Then you can grep the AST, which is basically you extract this AST and then you grep things on the AST. Using this approach, you are more accurate. Like, for example, if you are importing a library in Python with a different name, so import foo as var, then var you assign it to a variable, and then you run a method on that variable, then a simple grep won't find that you are invoking this method on this library that you imported. But if you use a static AST-based grepper, then can find this kind of calls, right? Now, in the other side of the spectrum, we have like full program analysis, static analysis solutions like CodeQL, which are able to perform things like data flow analysis. So following user control data through the application as if you were running the application. They can perform control flow analysis. They can perform different layers of abstraction to the code and performs really accurate and precise analysis. Or you can also run things like CodeQL in a very simple way, like matching the AST. So it's up to you. Like CodeQL, you can think it as a Swiss knife, where you can basically use the most powerful tools, or you can just basically, if you want to find all the calls to a given method and just rep the AST for that, then you can just write a 2-line query that will basically do that. And this will be really fast, and this will integrate very well with CI pipelines. Now, if you want to go to the opposite side of the spectrum, with CodeQL, you have the possibility to go all the way down to the both sides or the both ends of the spectrum. And you can go to the full program analysis, where you will be able to run like really powerful data flow engines and taint tracking engines on your code to be able to find this kind of injection issues where you have untrusted data entering your applications in one place and then following down through multiple libraries, interprocedural calls until they reach a sink or a place where some dangerous operation happens using this untrusted data.
So if someone wants to get like roll up their sleeves and start writing queries, is there any repo of good queries that they can start with as an example? Or
all the queries are open source. You can just go to github.com/github/CodeQL, and you will find all the queries are open source. So you can find the source code for all the queries for all the languages. So we support like, I think, up to 9 different languages. And also, if you want to start writing CodeQL queries, there are like a bunch of learning labs in GitHub. So you can just basically search for GitHub Learning Lab CodeQL, and you will have a bunch of them for different languages, like, for example, JavaScript, Java, C++. And these learning labs are based on finding real vulnerabilities that we found in the security lab. And then we created this learning lab about how to start from scratch, not knowing or not even having CodeQL install it, learning the basics, and then finding a real security vulnerability using CodeQL. So those are like really good resources to get started with CodeQL. And something that also, if you want to get started in this CodeQL journey, if you are looking for a motivation, an economic motivation, then we are running this bug bounty program, where if you submit a query that finds bugs in open source projects, or is covering a vulnerability category that is not already covered by the default rules or the default queries, then you can submit that to our bug bounty program and then get rewarded from, I think, like $1,000 to maybe up to $5,000-$6,000, depending on the scope of the query, on the complexity of the query, etc. But I think this is a very good motivation for people to learn CodeQL, use it for their own research, but also contribute those queries back to the community. So all the people that is running CodeQL in open source projects can run those queries as well and then get rewarded for that.
Yeah, that's awesome. Having that library of queries and just being able to lurk around there. Do you have any best practices for writing queries, or any like mindset that you use for writing queries to give maybe less false positives?
So I have some mindset about thinking about the code in the way of a database. Like, for example, imagine that you have a database with all the constructs in the code. So you have a table for all the method definitions, another table with all the method calls, another table with all the variables, another one with all the variable accesses. And then you're basically just joining and querying those tables. That's kind of help you getting started with this declarative language with CodeQL. But in terms of reducing false positives, this is more related with starting with a broad query, like, for example, finding all untrusted data flowing from any untrusted source to, let's say, for example, some code execution sinks, right? Then if you start with that, you will find probably all the true positives, but you will also have some false positives because the code may go through some sanitizer nodes in the data flow graph. So some places in the code where maybe the untrusted data is checked to be an integer, for example, or maybe it's checked against an allow list and it's only allowed to be one of a certain values. Then you may want to write some sanitizers to improve the accuracy of the query and then make it like more precise, right? So if you start like writing sanitizers, then you will start removing false positives. Then start like very broad, very general with the easy query, like from source to sink. And then if you start getting false positives, then you can just refine the query and add sanitizers to exclude certain paths that flow from the source to the sink, which may sanitize the data provided by the user.
How does your current setup look like? How do you work with CodeQL? What IDE do you use with it, and how's your setup?
So my setup is completely different from, I would say, 99% of the people using CodeQL. So I'm not a good example of that. But I'm a really, like I said at the beginning of the talk, I'm a kind of old person now, and I'm really into Vim and NeoVim, to be more specific. And I developed my own NeoVim plugin to work with CodeQL. So the way or the IDE that I use to work with CodeQL is NeoVim. So basically, I just use the terminal and NeoVim, and I write tests and develop everything
over Vim.
That's a good question. So at some point, NeoVim was like a fork of Vim, where they started developing things that Brad, which is the main maintainer of Vim, was not accepting as pull requests. Things like being able to run async jobs in NeoVim without blocking the whole editor. So in the past, if you were running like a linter, like for example, you mentioned the linters, you had to wait for, this was the same process, right? So it was blocked until the linter finished, and then you had your editor like blocked, and you were not able to type anything until that finished. So Thiago Forte, I think is the name of the founder, if you want to put it this way, of the main maintainer of NeoVim at that point in time. I think he says he's no longer working actively in this repo. But at this point, he submitted some pull requests to Vim that were not accepted. So he decided to just fork it and create a forkware. A more modern version of Vim would be possible. And then from there, people started contributing crazy ideas, which were at that time not accepted. So I think that Vim has changed their mindset in the last year. So they are now able to run async jobs and other crazy things that are being implemented in NeoVim, like, for example, 3-seater support for better highlighting, for better movements around the code, etc. They are also being ported back or implemented in Vim. But now, these days, is Vim playing the catch-up game with NeoVim. So NeoVim is ahead, like developing all these crazy ideas, like, for example, LSP integration, like language server protocol integration, to make Vim a really IDE and not just like a text editor. And, soon after Vim implements that as well. But NeoVim is more
That's
like
amazing. I use that for Rust when I write Rust code all the time. LSP to do it remotely. It's awesome.
Yeah. So think about writing this data without an LSP server, with all the lintering, etc. that LSP provides. And with CodeQL, going back to the question, the official extension, the official ID is VS Code, and you have like the official and supported CodeQL extension that will provide just the means to run the queries, to browse through the results, etc. Also an LSP server, but because of the way that they implemented this CodeQL extension with an LSP server, like a query server, etc., you can just write your plugin for a different text editor or a different ID. And for example, what I did is basically just to use the CodeQL LSP server that is already developed and is connected to the VS Code extension. And I just can call it from NeoVim without writing like a lot of lines of code. It's very easy to integrate into NeoVim.
Basically, just using the API almost.
Yeah, I'm basically using the API for the query server, and which is in charge of running the query and getting you the results, and the API for the LSP server, which will provide you with errors, warnings, hints,
awesome
things about your query, so you can get feedback for your query.
Cool. And this is available on GitHub, right?
Yeah. So the official extension, as I said, is VS Code with the VS Code extension. That's what people should be using unless they are really crazy into Vim or Emacs, because there is another guy in my team that is the same crazy as I am with Vim, but with Emacs, and he wrote his CodeQL plugin for Emacs using a lot of parentheses, I guess. But yes, you have now those three choices. You can also use the CLI, because you can basically just write your query in Notepad if you want, and then just run it using the CLI, where you basically define, okay, I want to run this query on this database, and just run it, and you get the result as JSON or as CSV or as a SARI file, which is a format to dump static analysis results, which is a standard these days. And then you can just open those files with Notepad if you want.
What have you found so far with CodeQL? If you've been doing it for 2 years, you must have found a lot of bugs. But do you have some highlights on some interesting bugs that you found during the way?
I have found many bugs. I focused on analyzing Java and also vulnerability categories leading to remote code execution. Mm-hmm. So I have found, I would say, hundreds of them. I really like one which I found back in the COVID days, 2020, probably a few months after the pandemic started, basically. So if you remember those days, there was these we call it radar COVID, which are these applications in your mobile phone. So if you got exposed to other people that were infected, you get a notification in your phones, right? Using the Android and the iOS notification and exposure systems. Basically, if you notify that you were sick, and then that was uploaded to a database, basically, and then if anyone was around you for more than 15 minutes in closer than, 20 meters, then you got a notification that you were exposed to the virus, right? Remember these applications? They were implemented in all countries. I think in Spain, it was called Radar COVID. But I found that the server for the German implementation of this system, the backend, was vulnerable to remote code execution. And the way that I found it is, well, first of all, I found a new pattern leading to remote code execution that was like a novel thing. So if you were using Hibernate validators, and this was kind of funny because you were validating your data, but because you were validating your data in a certain way, you were actually making your application vulnerable to remote code execution, right? You can look for that. I think the official name is like Vim validation. But yeah, I can even provide you with a link to this article that we wrote. And then this application was validating the data that you could submit to these radar COVID systems, and then they were validating it, making sure that it was following certain constraints and limitations. But because they were doing that in an insecure way, you were able to trigger and get remote code execution on that German server you could basically disrupt this certification system for the whole Germany, for the whole Germany. So that was a little bit crazy, but SAP were like the people maintaining and developing most of the code, even though it was open source, because the whole idea was to build trust on these applications, because there were like certain concerns at that time that people may get spied because they were installing things on their mobile phones and they were going to be able to know where you were like based or where you were located, etc., things like that. But those applications were made open source, so everyone could see that the application, both the mobile application and the both end were not taking any privacy information, any sensitive information, etc. This application was developed by SAP, and they were very quick to fix the issue and publish the fix. So yeah, back to the CodeQL, I found this by modeling a pattern that I found myself. So I found it myself in Nexus, which is a Sonatype artifact repository. Mm-hmm. And then I ran it on Nexus. I found a couple of instances there. Then I reported to Nexus, Sonatype. Then I wrote a model, talking back to this variant analysis concept. I modeled this pattern using a CodeQL query, very simple one, maybe 20 lines of code. And then I ran it on Nexus. I found other one that I missed. So I reported that one as well. And then I ran it on open source projects. At that time, there were like 20,000 Java projects. And then I found it in many projects. We reported the issue. And one of them was this COVID radar system. I don't remember the name for the German implementation. But yeah, I would say that one was one of the most interesting because of the impact and the criticality at that time, at that point in time with COVID.
That's awesome. That's pretty. How fast did they patch it?
It took them like a couple of days. No more than 48 hours, I guess. So they were very, very, very quick with that.
Cool. What is that? So I guess you look at a lot of security vulnerabilities that get released all the time. What is the latest, most interesting security vulnerability that you read?
Sorry, say that again.
I guess you look at a lot of security vulnerabilities all the time and try to write queries for it. What's the most latest interesting vulnerability that you read that you thought like, wow, this is a really smart, innovative way they found here?
So these days I'm more into managing the team that's writing CodeQL queries myself. But I've been, as I said previously, during the weekend, maybe I read like a couple of blog post write-ups about vulnerabilities that are being disclosed. Like, for example, the other day, this Cobalt Strike vulnerability in remote code execution by some clever injection in the HTML code that is being rendered in the swing components of Java. And then the Monday after, I came back to work and I wrote a query for that and found a couple of instances of other applications that were vulnerable. This was like a couple of weeks ago, so we are still in the process of reporting the issue. But I think that was the latest one. Other than that, I've been also modeling some JavaScript frameworks that we use internally at GitHub, but they are also open source. So these queries are going to be contributed back to the community. And I've been surprised, if you want to put it this way, by how powerful a CodeQL is. Because as I said, I've been using other static analysis solutions in the past. And with CodeQL being a declarative language, I thought that it was not going to be possible to do things that it was not even possible in other solutions. So it was like out of the possibilities of static analysis. But I wanted to implement that. So I asked the engineers and they told me, yeah, sure, you can do that. And they taught me how to do it. And I was like a mind-blowing moment of, wow, if you can do this with CodeQL, you can basically model anything. You can even develop your own abstraction layers on top of the abstraction layers that are already provided, like the data flow, the control flow. And you can, so there's no real limit of what you can do with CodeQL. Basically, you really need to get into it because it's like more advanced concept. But if you get into CodeQL, you can get for granted that you will be able to model almost anything, any pattern that you may think about.
I feel like CodeQL is just this new, amazing new static analysis tool. Is there any tool that you would like compare it to, or any framework?
Well, you can compare it with any other of the static analysis solutions out there. I think they serve different purposes. Like, for example, I'm seeing a lot of traction with SEMgrep these days. And I think SEMgrep is a great tool as what they call guardrails enforcer. So basically, you want to make sure, like, maybe not detect a complex SQL injection flowing from this specific user control parameter in through like multiple layers of abstraction in the procedural calls, calling back and forth from library code, etc., until this untrusted data reaches a sink. I don't think that's SEMgrep is apt to try to find this kind of vulnerabilities, but they are very good at enforcing things or policies like don't use, for example, if there is this flow through very complex code and CodeQL can get you the whole path from the source to the sink. SEMgrep is more about don't use that sink from the start. So if they find that you're using this sink, then they don't care really about if there is an evidence of untrusted data flowing into that sink. Maybe there's a policy that you should not use this sink at all in your code. So it's like a guardrail that protects you and keeps you in the road. But also a different approach for static analysis is more located in the other end of the spectrum that we were commenting on before, like repping in the AST and using that to enforce like good practices. Also, I think that CodeQL, SEMgrep doesn't require you to learn like a new language. Like CodeQL is a completely new language, a declarative language that you need to learn. And with SEMgrep, I think I haven't really used SEMgrep a lot, but you can just write your queries on the same language that you're querying. So if you are querying PHP, you can just write some simple queries using PHP-ish code, right? And that's kind of make it more accessible or easy to use for people that are not willing to invest into learning like a new language, even though the potential of those languages is completely different and what you can do with CodeQL and what you can do with SEMgrep. But what you can do with SEMgrep at the cost of not learning a new language may be enough for some people. So yeah, I think that's
how steep would you say the learning curve is for CodeQL? Is it like, hey, I can roll up my sleeves and I can do it in a weekend, or like 2 weeks of research and
So I thought that the learning curve was very steep. That was my impression. But what I learned the other day was we were having a conversation with someone that ran a CTF based on CodeQL in their university. So they got like 30 participants and they had to solve like 10 different challenges using CodeQL. And these participants hadn't used CodeQL at all before. And then after 3 hours of competition, they were able to solve 90% of the challenges.
Wow.
So these are 3 hours. They were able to, there are like a couple of tutorials for CodeQL so they are the learning labs that I mentioned before about real world vulnerabilities found with CodeQL that you are guided to find using CodeQL. And there are these other tutorials that are called the detective tutorials, where you use CodeQL to as a detective to solve some crimes and some mysteries, but they are not even related with a programming language. You are using mostly pure CodeQL, like trying to figure out and follow hints and solve some things. Some crimes is more like a game. And they solve the 3 tutorials that are available plus a number of vulnerabilities, model some vulnerabilities in CodeQL in 3 hours. So I was really surprised. So these are students from a computer science course in Germany. 30 of them. I don't know if it's a good amount to draw some conclusions, but I was surprised because I thought the learning curve was steeper than that. So
That's pretty incredible. 3 hours.
Mm-hmm. Yeah. So I know these people are used to CTF games. So they are into security, they are into programming languages, but they were not into CodeQL. And they were able to grasp the basics and actually model a couple of vulnerability patterns, like missing hostname verification when checking an SSL connection, for example, and other vulnerability categories in just 3 hours. So I don't know, maybe myself, I was not able to do that back in my college days, but these new generations are smarter than we were.
They're going crazy. Yeah. Awesome. I think we gone through most of all of my questions. Is there anything I have forgotten to ask about CodeQL that you think is?
No, I just want to take the opportunity to invite everyone that is interested into joining our Slack channel. So I will send you the invite so you can share it with the audience, maybe.
Yes, I will put the link in the show notes. So you will have the link to the show notes just under so.
Cool. That will be great because there is a very friendly community in this Slack channel and you can ask any question. And maybe if this learning curve is steeper for you than these 3 hours, then you will get a lot of help in this Slack channel. And also remember that there is this bug bounty program that we are kind of promoting, because I think it's a great win-win situation where you contribute queries and you help a lot of people, because those queries are going to be run through code scanning in thousands of open source repo, people that are just developing their own applications, projects on their own, that they don't have like a security team behind them. So by providing them with this security knowledge in the form of a CodeQL query, you are helping a lot of people. And this is really fantastic.
Is there any cool future CodeQL features that are currently coming out that you're excited about?
Probably the one that I'm most excited about are still not public in the roadmaps, so I cannot comment on them.
Okay.
But there are exciting things in CodeQL world that are coming hopefully very soon that will make analysis and modeling libraries and code much easier for people, for developers especially.
That's awesome. And how do all our listeners keep up what you're doing? Do you have and how is the best way to talk to you on the internet?
If you want to reach me in social media, my handle in Twitter is PWN so PWN tester. And I'm not very active on Twitter, but I read every day. So even though I'm not posting a lot of stuff there, just from time to time, you can reach me, send me a message there and I will read it. And yeah, that's basically the social media, the social network that I use the most. Also, you can reach me through this Slack channel as well. And if you want to follow the GitHub Security Lab as well, you can follow GH Security Lab in GitHub, or visit our website in securitylab.github.com.
Awesome. We will have all that link in the show notes. Perfect. Thank you so much for taking the time with me today. And thank you for letting us know about CodeQL. I'm really interested. I'm going to go and write some queries. And yes, thank you for coming on Hackathon.
No problem. It was a pleasure.
To all our listeners, thank you for listening to this episode, and I'll see you in the future.